formula for it? Nope. For the best. On Friday, it only let me use the back of the pen and not the front of the pen. That was real. All right. Let's see if today it joins us. So remember we had that formula, y minus y1 equals m tan x minus x1, which is just point slope form. Because it gave you a point and a slope, and you fill it in and you get point slope form, correct? Now, what we can do is we can rewrite that by moving the y1 over. So we could go y equals m tan x minus x1 plus y1, technically. True statement? So instead of writing it as y's, we can write it as f of a, meaning f at some specific x value, right? So we always plug an x value in there. And then we would have m tangent at a specific x, and then we fill in our specific x. True statement? Right? You fill your x in to get your y. So the linear approximation formula is just this formula with the y by itself. So we move the f of a over plus tangent at a, x minus a. So it's not a formula you need to memorize. You literally just need to know that all you're doing is getting your point slope form and y equals. That's it. So if it ever asks you to do a linear approximation, it's needed in y equals. Now what is a linear approximation? I'm going to scroll you to the very bottom. So here it says, the idea behind local linear approximation, also called tangent line approximation or linearization, is that we will zoom in on a point on the graph and notice the graph now looks very similar to a line. This means that we can use the tangent line, which rests in closeness to the curve around a point, to approximate other values along the curve as long as we stay near the particular point. What the heck is that? Well, if I had a parabola, okay, and I had a point here, let's say it's at 2. I could find a secant point at 2.1, and it would run very close to my tangent line, wouldn't it? 2.1, if I found the slope between 2 and 2.1, it would run really close to my tangent slope, wouldn't it? If I do 2 and like 10, which would be over here off the board, and did a secant slope of those, would that be close to my tangent slope? No, remember we talked about this in limits? You actually have to pick points that are very close on both sides, and if you get closer and closer and closer, you'd actually find the tangent slope at that value, right? So this is what this does. It just does local linearization. So we're going to go back here. It says, find the linear approximation of f of x equals 1 over x at x equals 2. So we're doing the linear approximation at 2. So now if we want to do the linear approximation and use that value, we're going to have to use something that's close to it. So like 2.1 or 1.9 you could use, because those are close to 2, correct? So if it ever asks us to just find the approximation of an estimate at 2.1, we can use the value 2 in the linear approximation for our a value, and then plug in 2.1 for our x. So that's what we're going to do and set us up. So the formula is y equals f of a plus f prime of a, x minus a. Our a in this case just happens to be our x, which is 2. So we know our a is 2. So we're going to fill that in. We're going to get y equals f of 2 plus f prime of 2. And then x minus 2. Can we find f of 2 and f prime of 2? Yeah. What's f of 2? We learned that in grade 10. Yeah, because you're just going to plug it in. F of 2 equals 1 over 2, correct? So I can go back here and I can go y equals a half. Plus. Now I have to actually find f prime. When I find f prime, then I can find f prime of 2, correct? So I have f of x equals 1 over x. What I tell you when you have a numerical numerator, did I tell you should use quotient rule, or did I tell you to do something else when you have a numerical numerator?
Bring it to the top with a negative exponent.
Bring it to the top with a negative exponent, and then you just do power rule, which is way faster. True statement. So we can write this as 1x to the negative 1. And then we can find f prime of x. Drop the negative 1 in front. Joins the 1. X to the what? Negative 2. Now did it ask us to do f prime of x or f prime of 2? F prime of 2. Remember, this can be given in a no calculator section on your AP exam, because you should be able to do 2 to the negative 2. 2 to the 2 is what? 4. What does the negative just cause it to do? Drop to the denominator, right? So if we have 2 to the 2, that's 4. 2 to the negative 2, we could rewrite this as 1 over 2 to the 2, could we not? That's how we get a positive denominator, which is 1 over 4. So you don't need a calculator for that, right? So it's going to be negative a quarter. So that's how I set up the linear approximation formula. Then I need to have a value that they ask me to approximate that's actually close to 2. If I set this up for 2, and then I want to fill in 9.6, we're going to have problems, right? Because it's going to be 2. 9.6 can be way here. It's not even be close to the tangent, right? It's not even be at all close. So this one asks for us to estimate 2.1. Is 2.1 close to 2? That's a true statement. It is close to 2. So I can take it and I can plug it in for my x now and get my linear approximation. So it's y equals 1/2 plus negative a quarter, 2.1 minus 2, which is just 0.1 times a quarter plus a half, which you're going to need a calculator in this section if they want you to actually turn to a decimal. It is 0.475. Now, I could actually find f of 2.1 equals 1 over 2.1, which is approximately, remember the squiggles are approximately, 0.47619, which is the actual accurate, and it is close, 0.475. Now, if you just type in 1 divided by 2.1 and give an answer, they're not going to say you linear approximated it at all because it's not the same answer, right? You have to do linear approximation. Now this one says, find the linear approximation of f of x equals square root x at x equals 9. Use the approximations to estimate root 9.1. Okay, so we still have to set up our formula. Our formula is y equals f of a plus f prime of a x minus a. You try that one out. Okay, so we want y equals f of what? What am I filling in for a? 9. Plus f prime of 9. X minus 9. Okay, so f of 9 is square root x, which is square root 9, which is 3. I'm so glad you know that answer. That'd be scary if you didn't. All right, then f prime of x. So if we have root x, that's x to the what?
Negative 1/2
Yeah, which would be 1/2
x.
negative 1/2, and we want f prime of 9, and we don't want to use our calculator. So we get negative 1 to the 9 to the negative 1/2. 9 to the negative 1/2 is the same as the square root of 9, but in the denominator. True statement? Mm-hmm. So what's 9 to the negative 1/2? 1 over 3. So we get 1/2 times a third, which is 1/6. So plus 1/6. And we want to practice without our calculators because half of the AP exam, to be accurate, the first and last part of it, have no calculator. Remember the 2 middle sections have a calculator and then you have to put it away? All right. Now what are we going to fill in for x? 9.1. True statement. And we should get y equals, where's my paper going?
So you just ignore the square root.
No, the square root's what we find out at the end. I'm just seeing what it is there. Yeah. 9.1 is the x. Yeah.
That's a weird way of asking.
Yep, and they can. So, y equals 3.016666, blah, blah, blah. And then the square root of 9.1, which is actually f of 9.1. My computer is going so slow, it's making my writing look terrible. Just go slow with it. Is approximately, I know I'm up here, I'm very important. Très important, some might say. Très important, some might say. That is not the right one. That's next answer. Just so you know, that's where it's going to go. We're going to get there. Just not right now. 3.016. It's writing so slow. It's making it look terrible. 206. All right, you guys try the next one. It's the cube root of 8.1. They could just say find the linear approximation of the cube root of 8.1, and you would need to know that f of x would have to be what? The cube root of x. And what could we pick that's close to 8.1? So they could just give this linear approximation of that without the equations. You need to know to do that. Right? All right. So here we're going to have y equals f of a plus f prime of a x minus a. That is supposed to be an a. We're going to put an 8 in there. Now, if I didn't give you what to estimate it to, you would just have a general solution with an x, correct? You wouldn't actually plug in any values, which is what you're going to do today in your homework. So we're going to have y equals f of a. So f of 8 is the cube root of, I don't know where I'm going with this. F of 8 equals the cube root of 8, which is 2. And then, how do I do f prime of x if x is to 1/3? 1/3 x to the, and now I want to fill in an 8. F prime of 8 equals 1/3. 8 to the negative 2/3. So, what does this mean? This means the cube root of 8 squared. True statement? Now, could I square it first, then take the cube root? Yes, but you're dealing with larger numbers. Why would you do that? That's crazy. So the cube root of 8 is 2. 2 squared is? And then it's negative. So it's a quarter. So we get 1/3 times a quarter, which is?
1/12.
There we go. So we get 1/12 x minus 8, but we're going to fill in 8.1. So it's technically 0.1 times 1/12 plus 2, which is 2.00833. And then if I find out f of 8.1, I actually get the cube root of 8.1, which is 2.00, shush, children. We're discussing math, so it's like I can't give you crap, but I actually don't know if it's math or if it's like the Dow has gone up. Okay.
He's talking about how he's memorized every single fraction.
That wouldn't shock me. Maybe you should. Challenge accepted.
Every single.
Up to 4 decimal places. We don't want to overachieve.
No, every
So
single.
like 3/4, 0.7500. I did it. You're welcome.
That's
4
not 3 decimal places.
I said 4.
I thought you said 3.
I didn't. We can roll back the tape. I said
Oh,
4.
yes.
Remember, if on the AP exam it doesn't say what we round to, what do we round to? 3 decimal places. That is not a true statement. You know. 3 decimal places, right? Sometimes it is saying where to round to now sporadically. I don't know why. I don't get the rhyme or reason. But it does say on the actual test to round to 3 decimal places unless specified. Like it's literally on the front of each section. So like it's not like it's like a sneaky thing. Like it literally tells you that in front of each section. Okay,